we need to verify these trig identities with our sum and difference formulas. So again, these will take a little bit of practice and a little bit of studying, but the sum and difference formulas are, and the double angle formulas are the most prominent that I've seen in our AP classroom questions. So study the formula if you haven't had a chance to yet. So sine of pi over 2 plus x is sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. And then thanks to our unit circle trig, we know that the sine of pi over 2 is 1 times cosine x, and we know that the cosine of pi over 2 is 0 times the sine of x. And that's the proof, because 0 gets rid of that term. 1 times cosine is cosine x. Similar process for the next one. So now we have sine of 3 pi minus x. So that's going to be sine of the first angle times cosine of the second minus cosine of the first angle times sine of the second. Sine of 3 pi, now 3 pi is more than a full circle, right? Full circle is 2 pi. 3 pi, or really any odd multiple of pi, will be in the same position as regular pi. So you should be using the coordinate -1, 0 here. So the sine of 3 pi is 0 times cosine of x, minus the cosine of 3 pi is -1 times the sine of x. So the 0 term will go away, and then we get positive sine x right here. All right, now the next two problems use the double angle formulas. So these tend to take a little bit more thought or a little more work than our sum and difference. So usually you're going to start on the double angle side. So our formula for sine of 2x is that that's equal to 2 sine x cosine x. And our formula for cosine of 2x, we've got a 1 here, so 1 plus cosine squared x minus sine squared x. Now, how do you know whether to replace a cosine squared or a sine squared or what? Take a look at the left side. Tangent x is sine x over cosine x. So it makes sense that I would want to keep the cosine squared and get rid of the sine squared in the denominator. All right, so let's look for a Pythagorean identity before we start rewriting things. I do have 1 minus sine squared, right? 1 minus sine squared is cosine squared. So I do have 2 sine x cosine x. There was already a cosine squared down here, and now we're going to say there's another plus cosine squared x. And we can simplify that in the denominator by combining like terms. So we now have 2 cosine squared x down there. And that's going to help because now things can cancel. The 2's can cancel out. The cosine in the numerator can divide with one of the cosines in the denominator to make 1, and we are left with sine over cosine. And that's equal to tangent. Now, in our notes, we did talk about alternative forms. Let me find this. Alternative forms for our double angle identities. So I could have changed cosine of 2x to just 2 cosine squared x minus 1. If I was looking ahead and saying, well, I do just want cosines in the denominator. But if that gets confusing, because sometimes I find that students get confused about which one to use, and then if you choose the wrong one, then you've got more work for yourself. So you can always choose the original and then sub out whatever cosine squared or sine squared that you don't want. So just keep that in mind. Okay, next one. Cosine of 2x equals 1 minus tangent squared over 1 plus tangent squared. So normally we start on the 2x side, but we've seen this expression so often, and I see a Pythagorean identity over there. And maybe this will be something. So let's start on the right side. And we will begin, like we have several times now with this fraction, by changing 1 plus tangent squared into secant squared x using the Pythagorean identity. That allows me to divide, or use our heart method, we call it. So 1 over secant squared is cosine squared x. And that's going to be minus tangent squared. Tangent squared is sine squared x over cosine squared x. Instead of divided by secant squared, let's say times cosine squared over 1. Now, I just did several steps at once there because we have seen this 1 minus tangent squared over 1 plus tangent squared quite a few times now in all of our practice homework and things before our first quiz. So if you want to show more steps than that, you can. I'm showing kind of the minimum here. Those cosine squareds cancel out, and we're left with cosine squared x minus sine squared x. And that is our definition of cosine of 2x. That's the double angle formula for cosine of 2x. Okay, back to sum and differences here. So cosine of 3 pi over 2 minus x. Now the cosine formula is cosine, cosine, sine, sine. So cosine of the first angle, cosine of the second angle. The sign in the middle is opposite, so plus sine of the first angle, sine of the second angle. Unit circle trig, the cosine of 3 pi over 2, which is this coordinate on the unit circle. The cosine is 0, times cosine x, plus sine of 3 pi over 2 is negative 1, times sine x, which simplifies to negative sine x. So I find that the sum and difference formulas are a little easier because the first step is using a formula instead of saying, well, we could start this way or whatever. So people tend to like these and find them a bit more manageable. Next one is going to be cosine of pi, cosine of x, minus, because that's a plus, sine of pi, sine of x. At pi, you're at the order pair negative 1, 0 on the unit circle. So cosine of pi is negative 1, cosine x minus 0 sine x. That simplifies to negative cosine x. All right, back to some double angles here. So again, I could work on the left side, but the right side looks more complicated. And anytime I see a Pythagorean identity, I'm tempted to start on that side. So let's start there. 2 times tangent x, we'll just leave it like that for now, over secant squared x. Now there's no addition or subtraction to be found here, so let's just start rewriting. 2 times sine x over cosine x. Instead of divided by secant squared, we can say times cosine squared over 1. That allows me to cancel out a pair of cosines, which leaves me with 2 sine x cosine x, and that is the formula for sine of 2x. Double angle identity, I should say, for sine of 2x. All right, for tangent x, we definitely need to start on the right side here. So again, I'll just remind myself, tangent x is sine x over cosine x. I'm trying to get there at some point. Now, we don't have formulas for double angles for cosecant or cotangent, so let's rewrite these in terms of sine and cosine. 1 over sine of 2x minus cosine of 2x over sine of 2x. We do already have a common denominator, so 1 minus cosine of 2x over sine of 2x. Let's apply our double angle formulas. So 1 minus, now I'm not going to use alternative forms for my proofs, but again, if you recognize that you're going right to sine x on top, you could use the one that's just in terms of sine x. So you could use this one, but I'm just going to go traditionally assuming that you're not going to be doing that. So if you're doing minus cosine of 2x, make sure you put in parentheses cosine squared x minus sine squared x. There's only one formula for the sine of 2x. It's 2 sine x cosine x. All right, so if I distribute this, 1 minus cosine squared, remember I want sine x in the top. So 1 minus cosine squared x is sine squared x. And then there's going to be another plus sine squared x. It's kind of like that problem we did a couple problems ago. Because I have sine squared plus sine squared, 1 minus cosine squared became the first sine squared. I can add those together, 2 sine squared x over 2 sine x cosine x. And I'm getting 2 divided by 2 to cancel to 1. Sine x divided by sine x divides to 1 as well. We're left with sine x over cosine x, which remember was the goal, so that we can say that that's equal to tangent x. Okay, number 9, applying sum and difference again. So this is the sine formula. Sine of pi over 6 cosine of x, match the sign, plus cosine of pi over 6 sine of x. What's the sine of pi over 6? 1/2 cosine x plus cosine of pi over 6 is radical 3 over 2. And look at how the right side has been written. A 1/2 has been factored out, which we can do. That would leave us with cosine x. And if you factor 1/2 out of radical 3 over 2, which is the same as radical 3 times 1/2, you would just be left with the radical 3 times the sine x. So that was a short little proof. For this next one, cosine formula, cosine of 5 pi over 4, cosine of x, change the sign, plus sine of 5 pi over 4, sine of x. Careful on your positives and negatives here. You're in quadrant 3, so both cosine and sine should be negative radical 2 over 2. And the last step, just like the previous one, the negative radical 2 over 2 has been factored out. And that would leave you with cosine x plus sine x. On to number 11. Now, I wanted to do this problem especially because sine of 4x is not, is not 4 sine x cosine x. It's not 2. I'm trying to think of what the common mistakes are. This is what people usually write. They usually write 4 sine x cosine x. So if it's not that, what is it? I can't think of the other way that people miswrite this, but I'll look at it. Okay, now this is sine of, remember, double angle, normally we have 2x here, but it's really 2 times an expression. So normally sine of 2x is 2, sine x cosine x. Well, really, the formula should be 2 sine of something, whatever was doubled, cosine of something. So if we have sine of 4x, the thing that got doubled was 2x, not just x. So there's no 4 to speak of in this equation right now. All right, and then what do? Well, then we apply our double angle formula. So 2 times, what is the sine of 2x formula? It's 2 sine x cosine x. And what is the double angle formula for cosine? It's cosine squared x minus sine squared x, which I need in parentheses because you're multiplying all of this together. You're multiplying this quantity in. And before you start distributing and multiplying, just take a look at the right side. We have the right side. The only thing we need to adjust is that 2 times 2 is, in fact, 4 sine x cosine x. So remember in the top where I said this is not just 4 sine x cosine x. That's part of it, but it's also times all of this. So if you have sine of 4x, it would be 2 sine x, sine 2x cosine 2x. If you had sine of 6x, that would equal 2 sine of 3x cosine of 3x. If you had sine of 100x, it's still 2 out front, sine of 50x cosine of 50x. All right, so you put the little half, split the angle in half. That's the double angle formula. All right, number 12. I want to start on the left side because I see some work to be done, and maybe I can, well, I guess it doesn't really matter which side we start on. I see trig identities over here too, so maybe that could be helpful, but I think I'll just start on the right side here. So let's see, we have 4 over sine squared 2x. Now sine squared 2x is probably better to write it like this. Sine of 2x squared. I know we don't normally do that, but if we're going to square this out, we want to make sure we do it correctly. The formula for sine of 2x is 2 sine x cosine x, and then we're going to square that, which is going to make it 4 sine squared x cosine squared x. Everything in the parentheses got the exponent. So the 4's cancel out, which is good because there's no 4 on the right side. We're left with 1 over sine squared, 1 over cosine squared. We're trying to get secant squared, so we have that. 1 over cosine squared is secant squared. 1 over sine squared is cosecant squared. And 1 plus cotangent is cosecant squared. So again, if you get kind of stuck here, start working on the right side and look at what you have and realize that you're getting there at this point. So it kind of helps you to work on the right side. You can't stop and get the two places to match in the middle, but it can give you hints for what to do as your next step on the other side. All right, next problem. Now, if you can recognize this as your alternate form, let me go back to the notes, of cosine of 2x, then this proof is done. So let's take a look at this. 1 over cosine 2x, done. Secant 2x. What if you don't recognize that? Well, then you'd have a little bit of work to do. You know that maybe you start on the right, maybe you start on the left side. This is 1 over cosine of 2x, and then you apply the formula, and then you sub out your cosine squared that you don't want, and you get there in the end too. So that's an alternative to match that side as well. Okay, for number 14, oh, this doesn't say that it's equal to anything. That's a problem. Let me see what it's supposed to be. It's supposed to be equal to cotangent x. Okay, so let's start on the left side since there's not much to do on the right. Change cosine of 2x to cosine squared x minus sine squared x. Sine of 2x is 2 sine x cosine x. What do we want from cotangent? That's cosine over sine. So let's get rid of the 1 minus sine squared and change that to cosine squared x, plus the other one we already have. So we've done that trick a couple of times. I'm just going to put a 2 up there. Over 2 sine x cosine x. So the 2's cancel. One pair of cosines cancel. Cosine x over sine x is cotangent x. All right, number 15. We're multiplying these two sum and difference formulas, so expand them out first. Cosine x cosine y minus sine x sine y. The other formula is cosine x cosine y plus sine x sine y. Looks like you have a difference of squares on the right, so we better FOIL these conjugates together. They are conjugates, so they multiply nicely. So use the shortcut. It becomes the first term squared, which means cosine squared x cosine squared y, minus sine squared x sine squared y. Now, what about this? What do we do here? We want the cosine squared x, but we don't want the cosine squared y. We want the sine squared y, but we don't want the sine squared x. We can't factor anything out because they don't have anything in common, but we can replace cosine squared y with 1 minus sine squared y, and we can replace sine squared x with 1 minus cosine squared x. That seems like it's complicating things, but let's distribute and see what we have. So distribute a cosine squared through. That gives you cosine squared x minus cosine squared x sine squared y. Think of this as a negative sine squared that you're distributing through. So minus sine squared y plus cosine squared x sine squared y. minus cosine squared x sine squared y cancels with the positive version, and we're left with what we want. So again, if you have some things that you want to keep and other things that you don't want to keep, take the things you want to get rid of and use usually a Pythagorean identity or something to replace it. Okay, what about this side? I think we should start maybe on the right side. It's got higher angles, and we don't have a rule for cotangent, so let's start. Let's start by using our heart method here and see what cancels out. So we get 1 over sine of 4x plus, let's change this to cosine of 4x over sine of 4x. And then it's divided by sine of 4x, so times 1 over sine of 4x. Okay, so this is telling me I could get a common denominator of sine squared 4x. The first fraction would become sine of 4x plus second fraction I already had cosine of 4x. Now, what are we trying to get to? Cotangent of 2x, which means we're only trying to get to, cosine of 2x over sine of 2x. So let's write these formulas out. Sine of 4x, again, remember it's 2 sine of 2x cosine of 2x plus cosine of 4x is going to be cosine squared 2x minus sine squared 2x. And then remember what we did down here. We said this is going to be 2 sine 2x cosine 2x, and we're going to square that quantity. Okay, so this looks pretty ugly, but remember, we want to keep our sines and cosines of 2x's, so don't go expanding anything else. Let's see, I want the cosine of 2x to be in the numerator here. So maybe I'll try getting rid of my sine squared of 2x. So 2 sine of 2x cosine of 2x plus cosine squared 2x. Let's replace sine squared with minus 1 minus cosine squared 2x. Okay, and in the denominator, let's make that 4 sine squared 2x cosine squared 2x. So let's see, does that get us anywhere? We get 2 cosine squared 2x plus 2 sine 2x cosine 2x. There's still a minus 1 up there. Over 4 sine squared 2x cosine squared 2x. Let's see. If we want to, we can't factor because this has a sine 2x in it. What could we do at this point? Maybe I made a substitution a bit too early. Let me see. I think I made a mistake somewhere in my work and I can't catch it. So I'm going to check what I did on my first one. Oh, this is why I'm stuck. It's not cotangent. It's supposed to be cosine. Well then, delete all this. Sorry, guys. Okay, this problem, yeah, it's probably not true that that's equal if it's cosine, if it's cotangent. Okay, make that cosine. This problem probably just got a whole lot easier. All right. Instead of doing heart method then, because nothing's going to cancel out, I'm going to expand what I have. I'm still trying to get cosine of 2x over sine of 2x. All right, so 1 plus cosine squared 2x minus sine squared 2x over 2 sine 2x cosine 2x. Oh, gosh, so much easier. Okay, we want to keep cosine 2x in the top, so let's get rid of this 1 minus sine squared 2x. That is cosine squared 2x. And because we already have another one of those, let's add them together and make it 2. And the 2's cancel, and a cosine on top cancels with 1 on the bottom. Cosine of 2x over sine of 2x is equal to cotangent of 2x. Way easier if you have the correct problem written down. All right, guys, that finishes this video. Come see me for office hours if you have questions on any of these, especially the double angle. Those are more challenging.